Perfect. So let's get started. So network operations at scale has three major challenges. Manual processes that don't scale, inconsistent deployments that create security risks, and validation that happens too late. In the session today, we're going to try to solve these challenges, applying the same principles majority of your developer teams, or if you're developers, you're already doing in your own teams, which is automation, testing, and policy-driven deployment. Welcome, everybody. This is NET323, Networks at Scale and How to Automate Operations. My name is Paulo Sanchez. I'm a Senior Network Specialist Solutions Architect at AWS. And with me, I have Claudia.
Hi, everyone. I'm Claudia Izquierdo. I'm a Senior Solutions Architect here at AWS.
Perfect. So what's the agenda today? Which one of you knows what a code talk is? Raise your hand. So not so many people. OK, perfect. So the agenda today is going to be intensive in coding solutions. So we will try to be here speaking less amount of time and just more interacting with you while we build something. But first of all, we wanted to kind of expand on these scaling challenges in AWS networking. What are the best practices for these automated network operations that we have seen in customers? We will explain briefly the use case that we are going to use as an example today. And then, of course, time to code. And then a little bit of takeaways for the session. We're going to be talking about all of the things, so which things we want you to take after the session today. So about these challenges, so let me start kind of painting a picture that maybe the majority of you kind of can relate. So a company starts small, small number of VPCs, just connect between them, a couple of accounts, and that it's easy to get full control, to know exactly how things connect, what's the security of this application, and of course, like make sure that everything is documented and it's working perfectly. But then growth happens, new VPCs come in, new accounts, mergers can happen, and then suddenly it's not a natural growth, it can be exponential. And those tight controls, or those controls initially for these small environments can become a bottleneck for a specific team. So usually cloud networking teams are not that big teams in comparison to the amount of resources that you guys need to manage. And then applications team, they're asking them to be agile, but then they need to start waiting time to get some approvals and to get some routes done or some specific security controls in place. And of course, these teams, because they want to be agile, they are, well, let's say that they're well-intentioned, hopefully a majority of the time, yes. They open a port, they open a security group a little bit more open that we would like to have to get that connectivity happening. And now we have configuration drifts, and now we have configuration that we don't know what's happening with them. And of course, like when we need to troubleshoot or when we need to know exactly what's happening with our environment, we're not really sure on what's happening. So kind of that's what we see, that when we grow, we get these three main things: this consistency and governance issues, manual configuration bottlenecks, and especially change management. We always tell like the cloud allows you to be agile, but then of course, usually we think like the network is something fixed, and that shouldn't be like that. The cloud network should also allow for change management without adding extra complexity into that.
So to face these three challenges that Paulo just mentioned, we are starting to, first one, adopt to work with multi-account environments, and these multi-account environments also comes with guardrails. So working with guardrails helps you to focus on permission control for the security of your architecture instead of only networking blocking. And with this, you can improve how to manage the security of your architecture, and with that, your network in AWS, and also to make this easier for everyone. And second is to manage AWS network services that we have here at AWS, but more specifically, the service to build global networks. So like Pablo mentioned, the task for all these network engineers, like creating Amazon VPCs, creating AWS site-to-site VPN, creating a routing table, adding routes, deleting routes, all of these different tasks can be optimized and help all these network engineers working with these global networks. And then go serverless. Use the different serverless services that we have at AWS, so you can deploy and automate these many different tasks that not only the network engineers has to do, but also the many requests that may be having for the many different users that are asking for help from these network engineers. So how does this look at AWS? First one, to start using AWS organizations. AWS organization is this service that we have at AWS where you can deploy multi-account environments, architectures, and also add guardrails, which are named service control policies. So first, start with AWS organizations, but then work with AWS Cloud WAN. AWS Cloud WAN is a service to build global networks, but not only building global networks, to build global networks with policy as code. So in this session, you're going to learn how to build these policies. So the idea here is to know a little bit more about AWS Cloud WAN and AWS Step Functions. Step Functions is going to help you to automate the different steps that are required to build the things that the networking engineers need help, but orchestrating those different steps that are required for this to happen and to help everyone in everything.
Perfect. So what's the use case we're going to try to use today to show you these best practices? So basically, we have an environment with, where the IP address management we want to be controlled by VPC IPAM. We want to make sure that teams don't create VPCs with IPs that are not into the IPAM pool that we are going to provide to them. We need traffic segmentation. The logic we're using today is we want to have a routing domain per environment. Dev, prod, whatever routing environment we have. We're going to keep it simple for today, but we want to have that traffic segmentation also in our network. We want to have traffic inspection. We want to make sure that everything is inspected between routing domains and anything that goes out to the internet. And of course, it needs to be low in operational overhead because we only have 2 engineers, the 2 people that you see right now here talking to you, only managing all that network at the scale. So what we have already built, and then I'll go to what we are going to be building today. So this is the organizations we have. We're keeping it simple, but definitely think of more than one organizational unit. But we have 3 accounts. We have the account that is going to be managing AWS organizations, 1 account, networking account in the networking organizational unit, and the spoke account in the dev organizational unit. In the networking account, we have defined Amazon VPC IPAM, with a root pool 10/8, and then to each one of the regions, we are defining a pool for the dev environment that we are sharing using AWS Resource Access Manager, RAM, with that specific spoke account. So the spoke account can only use the IPAM pools we are sharing. On the network level, AWS Cloud WAN, we have an initial version of the network, and we're going to be building more during the session today. We have a hybrid segment and a dev segment. I think we also have a prod segment. So we have like some segmentation already created. And we have, for the ones that don't know, we have service insertion. We will explain later in a moment, but that's our way in Cloud WAN to automate the creation of inspection by just simply telling the service, hey, I want to inspect these 2 or these 2 segments, or between a segment or things outside of to the internet. But we have already created that inspection segment, which is called a network function group, and our 3 inspection VPCs with AWS Network Firewall already created them. So we are just going to be creating the inspection itself. And of course, AWS Cloud WAN is created by AWS, is shared using Resource Access Manager with the rest of the accounts.
But Pablo, don't you think that everyone is here to learn a little bit of coding?
Yeah, so we're going to be coding. I think we took 10 minutes, which is exactly the time we were thinking about. So let's go into with the different requirements. Let's go with the first requirement, which is VPC IPAM as only IP allocation source. So what are we going to do? First, we're going to show that by default, I can create non-compliant VPCs, just to show that that by default, yes, someone can create something outside of the VPC IPAM. Once we do that, what we're going to do is create a service control policy that only allows creation of VPCs with the IPAM pools shared with the account. We're going to do the same creation and we're going to get it denied. And afterwards, we're going to be starting creating the different VPCs. So let me change to the demo and let's go for it.
Thanks, Paulo. So I'll be walking around here. So if you have questions, please let me know. Remember, this is an interactive session, so the idea is to hear from you too. So Paulo, can let us know what are you coding, what type of coding it is, why are you using Kiro?
Yes, so well, first of all, I'm using Kiro. If you don't know, it's our IDE that also allows us to use Gen AI agents. We're not going to be doing the help of AI agents today. It's going to be Pablo AI. But then what I'm using is a VPC Terraform module. We're going to be coding everything today in Terraform. A VPC module created by us that are maintained by us, by the networking team in AWS, just to create, where I'm going to start creating that non-compliant VPC, and then I'm going to move to put the SCP in AWS organizations.
Thank you, Paulo. So the idea in here is that we are just getting started. This is IPAM. IPAM is, as Paulo mentioned, is trying to stop someone to deploying IP address that it's not allowed. And why it's not allowed? Because Paulo and I, as the networking architects and engineers, decided that that's the pool that everyone has to use, or it's divided by the different segments, that it's based on the best practices that he and I just decide. So the idea here is to work with IPAM to use that pool that Paulo and I decide, but service controls policy from an AWS organization, it's going to help us, so no one is going to deploy a network that it's not allowed. So back to you, Paulo.
Yeah, so basically, right now I'm creating that VPC. So I'm coming here, I think I'm creating North Virginia. So basically, now, I guess you see it now better, right? Mm-hmm. So now we have that mock VPC that is not compliant at all, because we're going to be using the 10/8, and we have the 172 range. So now I'm going to add AWS DSCP to block that specific action to happen. Let me start by destroying this, and then I'll move to the part of the code for AWS. Yes, and then I'll remove this. Perfect. So if I move to my organizations folder, I already have defined the SCP, and the only thing I'm going to do is going to create the resources to deploy in my organization's account. Basically, what I'm doing is denying any creation of a VPC and also association of a secondary CIDR block. Now, I don't want anyone cheating after they created the VPC with the IPAM pool. So denying these two actions if there's no IPv4 IPAM pool true. And also, because we're controlling which IPAM pool we're providing to the dev account, we're controlling that is the specific IPAM pool that they can build. So I'll create the two resources right now.
Thank you, Paulo. So who from the audience is working with IPAM? Okay. And who is working with AWS Cloud WAN? Great. I love that. So the thing in here is to let that only Paulo and I, as the network specialists, to design what IP address can be used by many of the other part of our team, because you know, /24, it's not for all the Amazon VPCs and for all the subnets. So if anyone has a question, please raise your hand and I will reach to you to see what question do you have. So Paulo, back to you.
Yeah, I'm still finishing, so
okay.
I don't think I can type and speak at the same time.
Don't worry.
So my question is, how can you share, maybe you need to RAM share a specific segment to a specific account?
Okay.
So I want to know, for example, if I have a situation where I dynamically create accounts, I want to make sure that specific siders or segments go to specific accounts.
Okay. So the question that, what's your name?
Miguel.
Miguel just asked is, how can you make that an IP address to be attached or go with a specific segment, like for example, dev or production? Paulo, have you done that before?
Yeah, give me a moment. I'm just troubleshooting.
Don't worry.
Yeah. Thank you very much. Definitely needed GenAI for this. What was exactly the question?
How can you make an IP address to go for a specific segment, like this is for dev, this is for prod, and things like that?
So you need to apply that logic more the way you share the IPAM pools currently. So you create your IPAM pools, and then like you do like when you are doing your infrastructure as code, when you do RAM to a specific OU, where it's dev or a test or production.
But then in the case that have, for example, accounts being dynamically created, I'll have to have some management.
Yeah, okay, so that majority of customers use Control Tower that you can use for CloudFormation or for Terraform, where you can do your account factory, where you can say, hey, if this account is dev, then this is the IPAM pool, and then of course this is your Cloud WAN or Transit Gateway. You do that when you create that account, you create your blueprint, and then when you do that dynamically, you just provide those kind of shared services in the beginning.
Would I need to have a specific account to run the Terraform?
I think yes, and I'm not sure, but definitely yes, you will need one account that is the one managing the account factory, and then push into the rest of the accounts.
Yes, best practices, it should be one main account to push everything from the other accounts in AWS organization and in AWS Control Tower. Yeah.
Perfect. So I already have the service control policy. As you can see here, I have the same JSON I shared you, but now created with our target or dev account. So I think I removed that. Let me see if I can put it back. Yeah. So now I'm going to try to create it again and see that now I shouldn't be able to create that specific VPC.
So Paulo, we have another question. Why are we using Terraform and not CloudFormation?
That's a personal decision. It's just like, for me, it's more native to write Terraform than CloudFormation, but that's on me. Yeah, all the resources. Yeah, all the resources that we are creating today, they're available in CloudFormation. Also, if you use CDK, we have layer 2 constructs for layer 3 also for these AWS networking services, yeah. Yeah, so I think I did that clear, but now if I do the apply, I should get the deny on the service control policy. So now what I'm going to do is I'm going to start typing our proper VPC configuration with the VPC IPAM pool configure.
Perfect. What's the question?
Is it possible to write the SCP policy without mentioning the IPAM pool? So basically just mentioning the class A range. So as long as your VPC gets a cider from the class A range.
So like hard code the IP?
Yeah.
Oh, okay. So the question in here is that if we can not use IPAM and go to hard code the IP addresses in the coding per se. So it's possible, but in here, like the thing is that with IPAM, you are not like hard coding, you are letting to IPAM to take advantage of, IPAM it's not only to like give you IP addresses, it's going to help you to keep control of your IP addresses. So for example, if you are close to not having enough IP addresses pretty soon, it will let you know like if you are not going to have enough IP addresses soon. And also it helps you, as Paulo just said, to like have a design and how you want to distribute your IP addresses. So I think that it helps more to have IPAM so you can, more than just like stop people from not using the IP address that you would like, to also have control and monitoring the addresses, the IP addresses.
Yeah, but for situations where you don't use IPAM, or you use a different IPAM source.
Yep.
Yeah?
Yeah. Mm-hmm. So back to you, Pablo.
Yeah, so now I have the version of the VPC created. So you see that the way we're doing is just defining the VPC IPAM pool, the net mask length, in that case is 24. Then we also are creating dual stack VPC, so also with IPv6. I'm cheating a little bit, just doing a classic copy paste and change the region. You see that we're using North Virginia, Oregon, and the Spanish region, just to show you like a multi-region solution. But yeah, and then here what I'm doing is I have some local variable where I'm obtaining the IPAM pools from AWS RAM and just putting it in a local value just to gather which is the IPAM ID per each specific region. So I won't create the VPCs now. I will do it everything at the end, so you see how everything will connect to Cloud WAN and all the automation it's running. So now we were able to show. Let me come back to these slides for a moment. To show exactly this, how our first requirement has been met. So now our VPCs are compliant in that sense, and they are able to get the pool from IPAM and not being hard-coded. So I think we can move to the second requirement, which is an easy-to-build global network. And for that, we have AWS Cloud WAN, but what do we need to do there? We need to do all this. Have inspection between routing domains, egress inspection, also between regions. If I have traffic between regions, I don't want to inspect in both regions. I only want to inspect in one. And the one in orange is the region I want to inspect for every pair of regions that I have. And also I want to do something quite cool in Cloud WAN, which is I want to automate how the attachments get associated to the routing domain automatically. So basically the logic I want to apply is that VPC attachments are associated to their OU's routing domain, and anything that is hybrid, so VPNs, connect attachments, so to integrate SD-WAN networks, and direct connects are associated to the hybrid segment. So that's what I'm going to be doing now, and using policy as code in Cloud WAN.
Perfect. So something really important that you are going to see now that Paulo is going to code that part, it's that he's going to work with something that is sent to and sent via. It's like the main part of the coding with AWS Cloud WAN. Sent to, it's used when you want to know what the network traffic is going to end. A sent via is when you want the network traffic to, before reaching the end, to pass in a mid part before going into the final destination. So for example, send to is like, hey, it's going to, the final destination is on premises or the internet. Send via is, hey, but before reaching the final destination, go through this part, and usually, as the architecture that we are working in here, it's AWS network firewall, an inspection Amazon VPC, or a third-party solution for security. So for example, you have an Amazon VPC that wants to reach the internet, and it's like, okay, send to internet, but send via to AWS network firewall, or send to Amazon VPC, but send via AWS network firewall. So you can deploy the finish or the end of the network traffic, but also the mid part before reaching that final destination. So back to you, Pablo.
Yeah, so give me a moment so I don't lose what I'm doing. So you see that I'm doing something weird, that is kind of this dynamic block. So if you have not worked with Terraform, this is just a way for me to create dynamically different blocks. Cloud WAN uses JSON, but in Terraform, to make it more easy to build, we use what we call a data source, that we do it in these specific blocks that then get translated to JSON. And then, like, because I need to create the edge override, which is the way I'm telling Cloud WAN between two regions, what is the region I want to use. What I did is define that logic outside of the policy document definition, kind of like creating a variable, and then just creating dynamically those blocks here. So if I need to do any changes, I don't need to go to the definition of the policy document. I can go to my variable, local variable, do the change, and then anytime I deploy again the policy document, I will get that updated. So now let me continue with the next block, because we did from prod to dev and hybrid, and we missed dev to hybrid. And now the last thing I need to do is the attachment policy. So I already have one attachment policy, which is getting the tag value of the attachment. And if the tag is inspection equal true, that means that it's an inspection VPC, because the inspection VPCs I have already connected to Cloud WAN. And now I'm going to do two more attachment policies, one based on the tag and another one based on the type of attachment. So give me a moment that I finish that piece.
Of course. So what you can see here is that basically AWS Cloud WAN works with segments. These segments can be across regions, and we are having dev segment, prod segment, and the security segment with AWS Network Firewall. Yeah.
If you were to automate this using GenAI, what tool would you use? I mean, Amazon Q can do this, or Keto also has.
Yeah, the question in here is how to automate this even more using GenAI, and yep, you can work with Kiro, you can work with Amazon Q Developer. Remember that Amazon Q Developer advises you like the next slide to write. It works also with AWS Cloud WAN. Yep. So the other thing that we are really excited with Paulo is that we just got announced a couple of weeks ago, I don't know if somebody saw it, that we are now having advanced routing with AWS Cloud WAN. Advanced routing is a new function where, like, you know, like adding many routes, like 100 routes, 1,000 routes, like every day of the network engineers. So the idea with advanced routing is you can add now filterings. You can now like inbound filter, outbound filter. You can summarize route. You can use BGP attributes, BGP metrics. So you can add that. So this can just to make easier the routing and your route tables. So it's freshly baked. So if you start implementing AWS Cloud WAN, also can take advantage of this new feature. So back to you, Pablo.
Yeah, so we have already created the new version of the policy document. Let me go to the console so I can show you how that works. So this is the AWS Network Manager console where Cloud WAN lives. If you have transit gateways, you can also take advantage of these Network Manager capabilities by just importing the transit gateways, but in Cloud WAN it works natively. So you see that my policy version it's the 15th, so we did a lot of dry runs before this session. That I have two different kind of aliases when I'm doing some changes. I have my live policy, which is the one that is currently deployed, the one without this attachment, the attachment policies, the service insertion routing and everything. And then the new version, which is the one we have just created. That is going to take some time to deploy, and once it's deployed, it will move to the live version of it. It will take some time, so of course, like maybe it's time for some questions, and also maybe we can move to the next section if it takes longer, because usually it can take longer if it's adding new region, removing the region can take some minutes. Now that we're just creating some routing, maybe it doesn't take that much. And also, you see that what I have already created are my 3 inspection VPCs attached to the network function group inspection VPCs. So that piece is already there. So now we can just create those specific routing. So it's already been deploying everything. So it's telling you which actions apply. The attachment policies are just applied automatically. Now it's going to be creating all the static routes. Do we have any questions?
Yes, I just had one in here, and that is if someone has permissions in the account level, can they bypass the service control policy? And the answer is no. Service control policy will always be up or over the account level permission that you have.
Yeah, exactly. And there was a question over there.
You defined what regions on your inspection VPCs was it look like? Did you also tell it whether you're inspecting on both the source and destination region, or just one of them? Is that part of it?
Can you repeat that? I didn't
If
listen.
you are inspecting both source and
Yes.
destination
So
region.
in service insertion, when you say, so let me come back to the definition. So when you say, where I have it here, like dev to hybrid, also is hybrid to dev. So it's bidirectional when you do it. So it's going to be between source and destination, yeah.
Right, but if you're going from US East 1 to US East 2, and you want to inspect both.
Yeah, so now that's where I define that. So for example, between US East 1 and EU South 2, so Spain, I'm saying that I only want to inspect in North Virginia. I can say by defining here dual hop that I want to be inspecting in both, but in that case we're doing single hop for the sake of the example. Cool. Then while we create AWS Cloud WAN, I think we can move to the third requirement, and then of course we have everything connected together. Okay. So what have we created so far? So basically we have all these. We have the inspection between routing domains, we have the egress inspection, we have the cross-region and the attachment automation. Do you think that we have met all these requirements? Or are we missing anything?
I think we're missing something, Paulo.
Yes. So thing is, we can do it. So we can meet that one easily, but just simply saying to everyone, hey, put your OU tag when you connect your VPC, or doing in the account factory that we mentioned before, doing it by default, that they don't need to do it. But what if someone puts the wrong value of the tag domain? They may be connecting to hybrid, they may be connecting to prod. So still we need, for our use case or requirement of, I want to make sure that new VPCs go to the right segment, and the way we define the policy document, we need a little bit of extra help to make that requirement to be met. And that's how we're going to enforce routing domains from OU using, again, AWS organizations and AWS step functions. So as we did with the VPCs, we're going to create another service control policy for the spoke OU and the spoke accounts that they won't be able to create the tag domain. It will be created from the networking account. So they can create any tags in the attachment, but not the tag domain, because that's the one that defines in which segment they're connecting, and we want to do it from the networking account. Once we do that, that's going to be denied, so they're going to be created the attachment to nowhere in Cloud WAN, so it's just an attachment without any association. And now what we're doing is, as part of Network Manager, we have the capability to get events from changes in the network. AWS Network Manager events are sent to EventBridge. I'm showing there Oregon, and why I'm showing Oregon, because the home region of AWS Cloud WAN, where the control plane resides, is Oregon. So all the metrics and the events are going to be populated into that region. So our EventBridge is going to catch those events. We're going to filter by only new VPC attachments. I don't want to get much events, only those ones. And I'm going to send it to step functions to do this logic. wait for the VPC attachment creation. That most likely is just like a measure to make sure that we don't start doing the logic before the attachment is created. I'm going to obtain the OU information from the account ID, because that's metadata that I get from the event. And I'm going to create the tag from the networking account. So we will see how after the attachment is created, it changes from no segment to the segment we want to be connecting. So that's what we're going to do right now.
Perfect. So we had a question back there, and I'm going to move now for that one. That the thing in here is, yes, we are using AWS Cloud WAN to deploy the network, but service control policy is the one that is helping us from someone to not deploying the things that we don't want as Paulo and I, as the network specialists, to be deployed. So yeah, as you saw at the beginning, there was only IPAN and service control policies. There were no AWS Cloud WAN, just to show you that you cannot like bypass service control policy or deploy other IP addresses that are not allowed, but it's not because of IPAN or AWS Cloud WAN, it's for service control policies. And I think we had another question in here. What was the question?
Yeah, the testing.
Okay.
Yes. So once we create the new policy for Cloud WAN, right, it's generated, and we see it's, we have a latest one and we have a current one. Is there a way to test connectivity before finally applying it, and if it fails, to go to previous version?
So currently we don't have that option. So you can of course, when you create the new policy, you can check what is changing before you, from Terraform or CloudFormation, it will do the approval automatically to not break the infrastructure as code way of working. But if you do it from the console, you can of course check what it's doing and see if there's any destroy action. Currently, we don't have the way to test that before live. What we have created recently is a Cloud WAN MCP that kind of helps you with different tools how to quickly check if the routing is happening once you have it in live, that policy document. And then, of course, you can always roll back to previous options if you don't. So. Yeah, so you can use reachability analyzer. Yeah. So we are exactly. So those tools are the ones used, but then you need the core network policy already live. So we're of course working two ways, because feedback is also like I may want to check this before I have it created. So we're working on that, but for now it needs to be live. Then of course use tools to understand if the network is properly defined, but if not, you can quickly roll back to the previous version of the policy via API or via the console, and then continue with your deployment. So let me go quick to the service control policy that I'm going to let create while I'm explaining everything. So what I'm doing is I'm denying the creation of any VPC attachment if there's this domain, there's this domain key, and of course denying any tag modifications. So I'm not allowing anyone to change the domain tag once it is created. So I'm doing that at the dev OU level. And now I'm going to be building the automation. I'm going to cheating on the automation side because I have almost created. I just I'm going to, it's coded. I'm just going to uncomment it, and we can discuss it while I'm while it's getting built. So I'm creating this from the networking account. Okay. So the automation, it's what we mentioned before, the event bridge rule that is capturing only VPC attachments and capturing the network manager events, but only the ones that are VPC attachment created. That's the only thing it's important right now. And I'm sending this to step functions. And to see exactly what I'm creating a step function is always better to check it from the console. You have a better UI. And yes, so if I go to my state machine, to the definition, so it's here, let me make it bigger. That's what we're doing. So we are getting the VPC attachment just to first check if the attachment is created. Majority of the times is going to be created already, just kind of like a safety measure. And then I'm obtaining the organizational unit from the account ID, getting the domain from that, from that OU. So in that case, we're making it simpler because the OU name is the name of the segment in Cloud WAN. But here, this step is maybe if you have extra logic that, okay, OU means non-pro, to add an extra logic in the step. And then we're creating the tag in Cloud WAN. So basically are 3-4 steps that allows us to get this extra logic into AWS Cloud WAN. So yeah, so with that, perfect. So with that, we have built we have built those requirements, applying the best practices that we mentioned before. No? So with AWS organizations, what we're doing is not putting the efforts on blocking actions that they shouldn't happen at the network level by just simply like denying actions or putting a firewall when we need to, or just to thinking that, okay, I don't trust anyone, so I will kind of own everything. No, what we're doing is creating those guardrails in organizations. So it's okay. No one is going to put a CIDR block that it shouldn't be, or it can be no one is going to put in their VPC a NAT gateway. So I don't need to just freak out if, or not allowing them to do specific actions. I know that they cannot put a NAT gateway, so yeah, go free and work with your VPC because it's your workload, so you should also work with your own network for that. Then with Cloud WAN, we built a global network in 3 AWS regions with less than 50 lines of code. No? So we will see later how VPCs will automatically connect, and the routing will be created automatically. And then finally, we had a step function. So we had this ad hoc requirement that that we needed to build some automation in top of that, and then we use 5 states to ensure that VPCs are only being associated to their corresponding segment. So now let's go and try it out. We're going to finish the definition of our 3 VPCs. We have a data center. Well, it's a VPC in Paris that is going to mimic a data center, and we're going to do a VPN. And we're going to see how the site-to-site VPN is going to get connected directly in the hybrid segment, and our spokes VPCs are going to first create it to know segment, and then our automation is going to kick in and move them to the domain routing domain. And then we're going to show how the automation works and get some more and show you more about the configuration on Cloud WAN before we finish the session. So yeah, so let me come back to the coding piece.
Yeah, so in here you can see that we have been working mostly with Amazon VPCs, but AWS Cloud WAN can work with Amazon VPCs, AWS site-to-site VPN, AWS Direct Connect. It can pair with AWS Transit Gateway, also with AWS Transit Gateway Connect, that it's the solutions to work with SD-WAN. So in here is that you can work with AWS Cloud WAN, not only with Amazon VPC, but also to help you deploy in the routing and everything that you need for the hybrid connections that it's pretty usual for many of our customers.
Yeah, so right now what I'm doing is, as part of the VPC module, the way to create the core network attachment is to defining, okay, this is my core network that was created, and that's why I have a local variable, because I'm checking that ID or that ARN from AWS RAM. And here I'm putting just the routes. So basically I'm sending any IPv4 traffic or any IPv6 traffic to the core network attachments. And the last thing I need to do is to create the subnet where I'm going to be placing that that attachment, and I'm making it dual stack by assigning an IPv6 block. And this is just part of the configuration in the module. Just we're saying that it doesn't require any acceptance, because in Cloud WAN you can also put some controls about do I want to accept the attachment before it automatically connects to a segment or not. So I can add some manual value. In our case, we didn't want to. That's why we built the automation to control that. But if you don't want to build that automation, you can add some manual control and just simply get notified when you have a new VPC to check it and maybe to approve the association. I'm cheating a little bit because I have already my private module just to create EC2 instances and and some endpoints to connect to. I don't think we will have time today to show end-to-end connectivity, but just in case we have the time, we are building some EC2 instances. So now I'm going to do the same in the rest of the environment. Yeah, any questions? Okay. Perfect. Okay, so that's on the Spoke account. I already have everything. Let's make sure that I did not mess up something.
Hey, is it possible to set up custom error
Yeah,
messages
I did
for
something.
SCPs?
I
Basically
did
explaining why an
in
action
all of them.
is blocked.
Let me check.
Like for the users?
Yeah, because we've
It-
avoided using SCPs for like
Oh,
tag
yeah.
enforcement out of fear that
Check this.
internal customers won't understand why they're
I'm
using
just doing a split, so I need to take the second item, which is the ID from the ARN. That's what I'm doing in this specific section. So now it should give me everything good. Was a question there, Claudia?
Yeah, we have the question that if we can send a message to customers that they are getting blocked by service control policy because they usually don't understand why they are getting blocked when they're trying to do something that service control policy is not allowing because it was configured that way.
I don't know. Maybe we will need to. Don't know if that's possible or not. Maybe we can take that later and then do a little bit of quick research if it's possible, or get you to the right person to answer that. But I don't know. I don't know. And then the last one is on the on-prem side. I have already created the VPN. So I have my customer gateway, my VPN connection. And the only thing I'm going to be creating is the site-to-site VPN attachment. So now once I create it, I can move and show how everything has been created, and just see how the different automation is working and how everything is getting connected to Cloud WAN. So let's it's on the networking side. So it's not creating anything. Oh no, I need to be in the on-prem one. Sorry. So the on-prem, so the VPN, even though I have another Terraform estate, so I'm working kind of independently for the on-prem side, it's getting built in the networking account. And this is why the site-to-site VPN attachment needs to be created. The attachment, maybe on the VPN, needs to be created in the same account where Cloud WAN resides. That's kind of the same way it works on the transit gateway. So let's go to our console to see that now we have our VPN, and the VPN already is getting associated to the hybrid segment thanks to the 300 policy attachment policy configuration, which is the one we can show it now from the console so you can see how all the logic and everything. And now the VPCs, for now, they're just being created without any segment. We will come back to them, to the attachments tab in a moment to see how they moved. Look at, for example, the one in Spain already got created and it's moving already to the dev segment. So now it's just pending the network update of the association and the propagation in that specific segment. So before that, let's go and check the policy version, and then we see kind of how everything is working. So even though we did a data source, Cloud WAN works with JSON. So what we did, or what it was already created, was the ASN ranges. So NEP in Cloud WAN is using eBGP, so we need to provide the range of ASNs that we want in the regions. Then the edge locations, so in which regions we want to create Cloud WAN, so in that case 3 regions only. And then we have the attachment policies. I already explained this one when we were doing that part of the code, but then the logic for the VPCs was, hey, if the attachment type is a VPC, and also the tag domain exists, I did a typo here, this should have been an AND. We can even update it later in a moment. If these two conditions are met, I want you to put you in the I want to put you in the segment that has the same name as the value of the tag domain. So with this attachment policy, I'm covering all the possible use cases for my VPCs if I do that logic of OU name segment or your own logic that you want to do in Cloud WAN. And then the last one is, hey, if any of these attachments are connected, so any site-to-site VPN, connect attachment, or direct connect gateway, I want you to put it in the hybrid segment. So I make sure that anything that is hybrid goes to that routing domain. And then I configure my network function group for my inspection VPCs and my 3 segments, dev, hybrid, and prod. We didn't use prod today, but it's just to show you as an example of how you can create different segmentation in Cloud WAN. And then lastly, we have the segment actions. As we were mentioning before, now we have routing policies to get you to do more advanced routing control, so filtering, summarization, advanced BGP capabilities like changing the AS path, changing the local pref, or changing BGP communities. But in that case, we're showing you how you can insert firewalls. So basically, we have the send to action. It creates a static route pointing to kind of a default for egress traffic to the inspection. But then we also have the single hop, the send via to between the different segments. And here you see that even though in my policy document I created the dynamic block, when it translated to JSON, it creates the override. So basically between these 2 regions, I want to use the first one, and then everything that we define in the local variable. And then we have it both for prod to dev and hybrid, and then from dev to hybrid, so we cover all the different use cases. Then let's go to attachments. How much time do we have? Okay, we have some time, so we're good. So you see now that the 3 VPCs already moved to dev. So let's go to our state machine to see why that happened. So we see 3 executions. So it was our 3 VPCs moving already to getting created, so getting the notification to event bridge and coming to step function. So let's pick one as an example to show you what happened. So here what I did is obtaining the VPC attachment, and I was obtaining 3 things, 3 variables in my in step functions. First of all, the AWS account, basically from the input, getting the attachment ARN, and I'm getting the account where the VPC was created, the attachment ARN, and then the attachment ID. First, choices state that just checking that from here I'm getting the VPC attachment, so I'm also obtaining the status of the VPC attachment. If it's available, so if it's created, I just move to the next state that I'm getting the organizational unit. So from the account ID, I'm getting the organizational unit, and in the other one, I'm getting the name of the organizational unit. And the only thing I'm doing now is tagging that attachment, so doing the cool thing in step functions is I don't need to build lambdas. Like in step functions provide native integration to majority of the AWS APIs. So I'm just directly calling the APIs for those services. I'm tagging the attachment with the dev domain equals dev. So if I come to my VPCs, I see that the tag is already there in domain dev. And the cool thing is that if now I'm in the Spoke account, and if I go to Cloud WAN, and I check my attachment, because that was created in the Spoke account, so this is shared with me. So here I have it. I see my I don't see the core network, but I see the attachments that I created for the core network that they share with me, I can also see those tags. Something cool, because for the ones you know, like when you do AWS RAM, the tags are not shared between accounts. But Cloud WAN is sharing those tags between accounts. So you can see and potentially control, unless we block it, as we did it today. You can also check the tags of that attachment, so you understand better why my attachment was connected to the segment. But also, for example, because it's a shared resource, I don't know where I'm connected to. I'm just simply connected to Cloud WAN, and I trust my networking team to have built all the routing for me. Okay, so I think with that we can start closing it up. First,
Yes. So, yeah, there is a repo you can start working with AWS Cloud WAN, service control policy, everything is AWS sample is the official repo where you can find these and many other solutions. And also you can start working with AWS Cloud WAN, specifically with guidance for attachment.
Before you move, so in the Cloud WAN blueprints, we already moved to version 1, and you have even examples for this advanced routing with routing policies. Feel free to check it, create issues, create PRs. We're really happy to get at least these blueprints where we can interact with you, and you can tell us, okay, I want to see that specific use case. The guidance solution is basically the same idea that we saw with the step functions, but for production real environments, or thinking on production real environments. So it helps you to create this extra logic into the attachment, in the attachment management of Cloud WAN, if you want to add those extra controls aside the attachment policy. And then, of course, some examples on service control policies. Yeah, sorry.
Don't worry. And then we have also AWS Skill Builder. This is the platform when you can find many different courses for free, some of them, and other one needs to be paid. And yes, we have specifically for network and content delivery, you can find in here more about AWS Cloud WAN and other networking services.
And as I said at the beginning of the session today, some key takeaways. You can forget everything that we said so far. This is the important piece. So the first one is architect by use case, not by habit. So what we have seen so far in customers is like as they're growing, they are just putting one specific service because that's where they found in the documentation, or that's where they're comfortable with, or their partner is comfortable with, and then everything needs to operate around this architecture decision. We see success doing the opposite. What's your use case? That's why we're here. Tell us your use case, and we can help you define which is the best service for your specific use case. And then of course, like the idea is like you don't have one service for everything. I know that it's of course like you need to be in the middle, not like, hey, yeah, let's use all the portfolio of AWS networking to do connectivity, but for sure it's not only one. Like we need to get define properly the use cases and make sure that we have the right pattern for the use case. And for that, we need to start with business outcomes and then architect for agility. So understand where we want to get, where we want the business to when and where they want to reach that goals, and then architect for agility. Infrastructure as code, modular designs, continuous iteration. Most likely you have really well-defined pipelines and automation in your applications. Take those learnings and put it also in your infrastructure, so you can also have that iteration. And services like Cloud WAN helps you to not have to control big infrastructure as code files with so many resources. You have everything in one single place. And they orchestrate beyond networking. We see that not only networking is the key, service control policies, organizations, security measures, automation, take full control of the portfolio of AWS, also to build the infrastructure that you want to get your business quick and to the goals that you have been setting up. So with that, thank you very much.